In this question, we are given a block of mass m 50 grams connected to a spring of a given value of k on a frictionless surface. So this is a standard example of a simple harmonic oscillator, and it undergoes simple harmonic motion with an amplitude of 4 centimeters. So in part A, the question is, what is the total energy of the system? Well, the total energy of the system is equal to the maximum possible potential energy, and as we know, the maximum possible potential energy is equal to Ka squared. So in general, potential energy would be Kx squared. The maximum value of x is equal to the amplitude. So the total energy of the simple harmonic oscillator is just Ka squared over 2. Well, if you substitute for the numbers, you will get 0.028 joules for the total energy. And then the question is, in part B, what is the speed of the mass when the block has a displacement of 1 centimeter? So if we know the value of x, 1 centimeter, what is the value of velocity at that instant? Well, we are said that there is no friction, so it's not a damping oscillations, so which means that the total energy of the simple harmonic oscillator is conserved. So we can say that E total, which is equal to Ka squared over 2, is equal to, at all times, the sum of potential energy plus kinetic energy of the block. Well, you can cancel out 2's and you get Ka squared, Kx squared plus mv squared. And so from this equation you can easily calculate for velocity. Okay, so let's do it here. So velocity here is then equal to k over m square root times square root of a squared minus x squared. So we can calculate that. We know k, m, a, and the value of x, it's 1 centimeter. So if you substitute for the numbers, you get 1.02 meter per second for the velocity when x is equal to 1 centimeter. And now, in part C, the question is, what is the potential energy of the spring mass system when x is equal to 3 centimeters? Well, that's a straightforward application of this equation. So U of x is equal to Kx squared over 2, that's potential energy. So we just substitute for the numbers. So U at 3 centimeters, that's 3 × 10⁻²⁰ meters, is equal to K, well, we know the value of K, so let's just substitute for the number, that's 35 times 3 × 10⁻² all square over 2. So this gives you 0.016 joules. Okay, so this is the potential energy of the oscillator at x equals 3 centimeters. And finally, in part D, the question is, what is the kinetic energy at x equals 3 centimeters? Well, we already know what is our potential energy, that's 0.028, and if we subtract potential energy at that point, that would be 0.016. So this is the total, this is the potential energies. And if you take the difference, you get 0.012 joules for the kinetic energy at that instant. And that's it.